Well, it's time to wrap up chapter 10 with 10.7. This is going to be a longer video, I anticipate, than some of the other ones. When we're looking at 10.7, we're talking about complex numbers, and this brings us to, we're going to revisit this idea of, at the beginning of this chapter, we said we couldn't solve this, that it was not a real number. Now we're going to learn that it does have a name. It's not a real number. It's imaginary. You probably didn't think that such a thing existed. Imaginary numbers. How we're going to handle this is you take the square root of 1, and when you simplify that, it becomes I. And you want to be very distinct with the little hook on there, especially if you're writing. When you are answering MyMathLab, there should be a place for you to choose the I. So let's take this square root of negative 16 and simplify it. So the negative will come out, and then the square root of 16, well, that's not a very pretty arrow, but the negative will come out as I, and the 16, so then the square root of 16 is 4, and we want to rearrange this so that our answer has the 4 in front. We can write all numbers as complex numbers. A complex number is in the form of A plus B I, where the A is the real number and the BI is the imaginary. And all numbers are complex. If you take a number 4, it's a real number. But if I wanted to write it complex, I would just add 0i. Or if I had an imaginary number 4i, I could write it complex by adding 0 to it. So starts out, with just the 4 or the 4i, but it can be written as a complex number by using that 0 as the coefficient for I, or here 0 as the constant. So we want to simplify these, and to do that we want to deal with the I before we take care of the other simplification. So let's deal with the I first. So the square root of negative 50, I can rewrite that as I times the square root of 25 times 2, that's my 50, and then I can simplify that as 5i times the square root of 2. When we're multiplying, we want to go ahead and deal with the I first also. So if we have a situation, the square root of negative 10 times the square root of negative 9. So remember, these negatives are underneath the radical. They're not in the front. If they'd be in the front, then we could go negative times negative equals a positive, but they're not. They're underneath. So what we want to do is we want to go ahead and take the i's out, and so we would have I times the square root of 10 times I times the square root of 9. And what we're going to end up with here is I can simplify this. I could go ahead and change it to 3. So I'm going to go ahead and just mark that out and say we're going to simplify that to 3. So now I have 3 times I times times the square root of 10, which can't get any smaller. Well, now I have these 2 i's. So what I've got is 3i squared times the square root of 10. But we have another rule to take care of this I squared. So I squared equals -1. So to completely simplify this, this becomes -3 times the square root of 10. We pulled the i's out first, then we multiplied them to get I squared, and then now we know that I squared equals -1. I'm in a class right now in Stephenville. Let me see if I can do a better job of this. And the instructor there is recommending that we go ahead and write the multiplication symbol with the asterisk, since that's what shows up on your calculator. And so I'm going to go ahead and start doing that. So go ahead and pull the i's out first. And we could go ahead and simplify this, but it's not going to simplify completely like the 9 did just a minute ago. So what I want to do is I'm going to go ahead and multiply what's underneath. So on the outside I have I squared, and underneath I have 36. And 36 can be simplified completely. And then remember, we want to take and replace this I squared with that -1. So -1 times 6 would give me a -6. Now here, because if we take out the i's, they will cancel. So when we're dividing, we could go ahead and take care of those negatives inside. Let's go ahead and see what happens. So if I take and put I here and I here, then those two are going to cancel. And so then I want to stick it all under 1 radical. So 70 over 7. And then I can simplify that by doing division, and I end up with the square root of 10 for my answer. Okay, let's go ahead and let y'all practice a couple of these. Before we move into the next part of this. So let's go ahead and practice a little. Okay, so you know the drill. Pause it and then come back and look at your answers. Oh, don't you love it? Just magically shows up. All right, let's go ahead and look. We're going to extend this lesson quite a bit today. So here I need to subtract this group from this one. And I'm going to go ahead and distribute that negative with both of these inside. So I'll have 7 plus 5i plus 3 plus I. Then we want to combine like terms. So we've got our real numbers, and then we have our imaginaries. And the reals come first, remember, when we're writing. And then 5 plus 1 gives me the 6. Okay, so we're going to multiply here and distribute. So 81i minus 63i squared. 81i plus 63. And then let's rearrange it to be written correctly. And so how did this 63 go from being a negative? What happened to the I squared? You want to remember the I squared becomes -1, and a negative times a -1 becomes the positive. Then it becomes our real number added to our imaginary number. Looking at this problem, what do you notice? If you watched the last video, then you probably will remember when the first and second terms in each factor are the same, but one has a positive and one has a minus or a negative, then our middle terms are going to cancel. So I'm just going to focus on multiplying the 6's together, the plus and the minus, and then our 7i and 7i. So 6 times 6, a positive times a negative. 7i times 7i would give me 49i squared. We want to take the I squared, change it to the -1. Then -49 times the -1 becomes a positive 49. And now everything is the same, so we're going to go ahead and add 36 plus 49 to get 85. So to us, it's probably a very unusual looking answer for what we started with, to go from something that looks very strange to a whole number in just one term, where we started with 2 factors, 4 terms. Remember, we also looked in that last chapter. Didn't mean to do the whole thing. Let's do that. When we looked at when we had a factor and it was squared, you've got to remember to write it twice. There is not a shortcut here. A lot of mistakes are made here by just leaving this and thinking, oh, -6 squared is 36. Yeah, we'll have a 36. 4i squared will give me 16i squared, and we'll end up with that too. But you miss the middle term if you don't write it all the way out. So you want to be sure that you do that. So -6 times -6. -6 times a positive 4i will be a -24i. 4i times -6, another -24i. Positive times positive, 4 times 4, I times I. We want to combine like terms and simplify. So I'm going to have 36 minus 48i minus 16. Remember that I squared becomes -1. Now we can put these two together and write it in the correct order for our answer. All right, so let's do some more practice. Okay, so go ahead and write everything down and then pause the video and then do the work. Do the math. All right, now that you're back, check your work. Here I went ahead and did, the FOIL and did everything and then showed you how the middle term, it cancels. So the quick way to do this is a 10 times 10 to give us 100. Negative times positive is going to be negative. 6i times 6i is 36i squared. And remember that I squared there becomes -1. That's how we end up with a positive 36. All right, so with the imaginary, can't have I in the denominator, just like we couldn't have the radical. So we're going to handle it the same way. We're going to rationalize and use a conjugate. So I'm going to multiply this times I. When I do, I end up with 6i over I squared. The I squared becomes -1. And to simplify it completely, becomes -6i. If I have two terms, it will be like we did with the conjugate. So I want to take and multiply by 6 minus 3i, top and bottom, numerator and denominator. So I'll have 48 minus 24i over 36 minus 9i squared. This is going to simplify for the bottom to become a positive 9. Then that becomes a 45. So 48 minus 24i over 45. Now remember, we always want to simplify if we can. And so remember what I told you earlier in another video. When we have 3 terms here, all 3 have to be divisible by the same number. So if we look at these 3, all of them can be divided by 3. But let's not do that now. Let's go ahead and let's separate it into let's write it as a complex number. So 48 over 45 minus 24i over 45. Now let's divide. Here we're going to divide by 3. And here we're also dividing by 3. And so this is our answer. Or we could write it like this, or we pull that I to the outside. What you cannot do is stick that I into the denominator, so be sure that when you're drawing this fraction line that it doesn't extend over your I. Okay, let's do some practice. Okay, there you go. Let's try these two. So again, write down the problems, pause the video, do the math, then come back to the video to check your answers. After I get to this point where I've multiplied everything out, then I want to go ahead and make a note of my I-squares. I wanted that to be in pink. That's -1, and this is -1. So 7 minus 2i plus 5. The two negatives make it positive. 1 plus 1 will give me 2 at the bottom. 7 plus 5 is 12 minus 2i. All of this is over 2. When we look, our 12, our 2, and our 2 can all be divided by 2. So 12 divided by 2 is 6, and -2 divided by 2 is 1, so what's left here is the I, and we're finished with that one. On this one, again, here we've got that, that's -1, this is -1. Now notice what I did in this problem to begin with. I noticed that 15, 18, and 3 could all be divided by 3, so I did that first. Divide by 3 and get 5, divide by 3 and get 6, divide by 3 and get 1. And that just kind of makes the math a little bit easier, because then I could just focus on doing the I instead of a 3i. Then at this point I need to take care of the negatives. So I have 5i plus 6 over a -1. Well, we want to rearrange that so it'll be in complex form. And then we need to bring the negative up, so we can make each of these negative. So all I did was divide that by -1, divide that by -1 to get this. I had already rearranged it in the complex format. Or you could leave the -1 to the outside, whatever you prefer. This next section we're still in 10.7. I told you it'd be a long one. It says to simplify. Now, I to the 37, I could write that I 37 times, but I don't know about you, but I just don't want to do that. And so I'm going to show you a shortcut to get to your answer. Because remember, I squared equals -1, and I squared equals -1, and so forth. I mean, we could write out 37 of these and do this, but it would take us quite a while. So we have a little bit of a shortcut. So the first thing you want to notice here is I have an odd exponent. When I have an odd exponent, I have two choices for my answer. My answer will either be I or -I. We just have to figure out which one. So what we're going to do is divide. Move this up just a tiny bit. So I have 37 divided by 2. 2 will go into 37 18 times, taking a little bit of a shortcut there, with a remainder of 1, which it really doesn't matter about the remainder. But what you want to notice here is that your quotient is even. And when the quotient is even, the answer is I. Let's do another one. So if we have, let's say, I to the 11. Now this one wouldn't be too hard to write out, all the i's. But we want to remember odd exponent. So my answer choices are I or -I. Take the 11, divide by 2, 5, and this is an odd quotient. So when we have an odd exponent and then we divide it by 2 and get an odd quotient, this is when our answer is going to be the -I. And if you'll just think about, here with that odd, an odd amount of negatives give me a negative answer. Our next problem, I definitely do not want to write out all those i's. So what we want to know is that an even exponent will give me an answer of 1 or -1. We're going to do the same thing we did earlier. We're going to divide by 2. And I get an odd quotient. When I get an odd quotient, remember what I said up here about an odd number of negatives will give us a negative answer. So an odd quotient is going to give me an answer of -1. So then let's look at another problem. Don't want to go too far. Another one that I don't want to write out, 1,016 i's, and I am intentionally making these very big so that you don't think about doing it that way. Again, we have an even exponent. That means my answer is 1 or -1. The process is the same. I'm going to divide by 2. And I get an even quotient. And with an even amount of odd numbers, I end up with a positive answer. You'll use this information that you've just learned to simplify problems that are a little more, with a little bit more work than just simplifying the I. So let's look at this. We're adding. So we already know I squared is -1. That's easy. We know I to the 12. So 12 is even. So that means we're looking at 1 or -1. When I divide 12 by 2, I get 6. And that's even again. And so that means we're talking about a +1. Do the combination and I have 0. If you're asked to write it in complex form, then it would be 0 plus 0i. Okay? All right, well, good luck with this one. It's different because you haven't thought about imaginary numbers. And so that's what's going to make it the most different. I'm not going to say difficult, it's just different. And if you'll take very good notes and refer to them as you do your homework, you shouldn't have a problem with this. But as always, if you do, send me an email.